Alright, here is a review of what we did with exponents and radicals back in Unit 2. So first of all, simplifying radicals. That, remember, is where you've got to make your tree in order to get out all the factors. So if I asked you to simplify the square root of 80, square root means that I can pull out any pairs in my factors. So let's start breaking this down to see what I mean. So 80 breaks down into 8 times 10. And then in order to really keep track, if you want to go ahead and kind of cross off the previous parts of the tree, that's super helpful too. 8 breaks down again into 4 and 2. 2 doesn't break down, but 4 breaks down into 2 and 2 again. 10 breaks down into 5 and 2. And now we start circling all of our pairs. So we've got one pair of 2s, so we can pull a 2 out front. We have another pair of 2s, we can pull another 2 out front. And we're left with a 5, so we're left with root 5. Now that breaks down to 2 times 2 gives me 4. So the square root of 80 is the same as 4 root 5. Let's try another example. Let's say this time I have the square root of, let's say, 200x to the third. Now, just because I've got a variable doesn't mean that this process changes at all. So 200 breaks down into 2 times 100. I'll cross off that I'm done with that. 100 breaks down into 10 and 10. Cross off that I'm done with that. Now x to the third, that breaks down into 3 x's being multiplied by itself. Now I can go through and I can circle I've got a pair of 10s, and I can circle I've got a pair of x's. And what am I left with? 2x. Now if you did this right, you should really always find you're left with just one of the variables or none of the variables underneath the square root, because anytime you have like an x squared, that can be pulled out. So then I have 10x square root of 2x. Alright, let me give you a final example to try on your own. Let's say I have the square root of 86x to the 5th y to the 3rd. So go ahead, no, actually we'll make that y to the 2nd. X to the 5th, y to the 2nd. Go ahead and pause the video and try this on your own. Alright, welcome back. 86, that breaks down into 43 times 2. That actually does not simplify at all. Yeah, because I'll double check 43 times 2, that definitely gives me 86. Yep, that doesn't break down. However, x to the 5th, that breaks down into 1, 2, 3, 4, 5 x's. 1, 2, 3, 4, 5. Now y squared breaks down into 2 y's. So we've got one pair of x's, another pair of x's, and a pair of y's. So out front, we have x times y. And underneath the square root, we're left with our 86. That didn't actually break down into anything helpful because both of those are prime numbers, times x. Because we brought out all the y's, you're not left with any y's underneath the square root. And now we can simplify one more time from here. X times x gives me x squared, y square root of 86x. Alright, now let's go through simplifying exponents. Let's say I have x squared over x. Start off simple. That means I've got 2 x's divided by 1x. That just becomes x. Now let's get a little more complicated. Let's say I've got x to the 3rd, y to the 2nd, all over x to the 5th, over y to the 3rd, let's say. So that becomes 1, 2, 3 x's times 2 y's over 5 x's times 3y's. So now we can cancel out all of our repeats, and we're left with what? We're left with just 2x's on the bottom times a y. Scoot that over. So then we just have 1 over x squared times y. That's the basic idea. So you always want to get it down to where I'm just dealing with positive numbers. Now let's get a little more complicated. Let's say I've got x to the negative 3 times y squared, all taken to the second power. So whenever I've got power of a power, I distribute that power, and that effectively becomes multiplication because I've got 2 groups of this. Or if that was a 3, I would have 3 groups of this. So that becomes x to the negative 6 times y to the 4th. Now what does a negative exponent become? That becomes a fraction, x to the 6th. With any of these examples, I'm not going to actually probably explicitly tell you to pause, but go ahead and pause the video before I go through it and then try the example on your own. Alright, let's try another one. Let's say let's get just wild and crazy, and we'll break it down step by step. Let me get another page and we'll do a wild and crazy example, as crazy as it'll possibly get. Let's say I've got a to the negative 6th, b to the 3rd, c to the 2nd, over b to the negative 2, c to the 3rd. All taken to the negative 3 power. So there's a ton going on here. Lots going on. But don't freak out. First thing you want to do, deal with the fact this is a negative exponent. I don't like negative exponents. So let's go ahead and flip around this fraction to deal with the negative exponent. So then I have b to the negative 2, c to the 3rd, a to the negative 6, b to the 3rd, c squared, all taken to the 3rd power. As tempting as it is to do more than one step at once, do not. It gets way too much going on. Just do one step at a time. Now I've still got some negative exponents, so let's flip those guys back around to get rid of the negative. So now I've got a to the 6th, c to the 3rd, all over b to the 2nd, b to the 3rd, c to the 2nd. Because everywhere I see a negative exponent, you flip it around on the fraction. If it's on top of the fraction, it goes to the bottom of the fraction. If it's on the bottom of the fraction, it goes to the top of the fraction. Alright. Now from here, I think there's 2 different equally valid ways you can do it. You can either go ahead and distribute the exponent, or you can simplify what's in the middle here. Personally, I think I'm going to simplify what's in the middle here before I start distributing the exponent. If you did it the other way around, you should get the same answer. So let's simplify the middle. So I've got 6 A's and no other A's, so that stays the same. I've got 3 C's divided by 2 C's. So what am I left with still? I've still got 1 C on the top. I've got 2 B's times 3 B's. How many B's is that? That's 5 B's. All taken to the 3rd power. Now I can distribute the exponent. So then I have a to the 18th, c to the 3rd, all over b to the 15th. And then I'm done. So backtracking, wherever you see the negative, go ahead and change that to a positive and flip around that fraction. And then again, wherever you see a negative, go ahead and flip those guys around. Then deal with simplifying according to the rules. I personally like to kind of simplify what's on the inside before dealing with this outside mess. Doesn't super matter either way you do it. Let's try another wild and crazy example. Let's say I've got b to the negative 10, c to the 3rd, a to the negative 6, over a to the 3rd, b to the negative 7, c to the 4th, all taken to the 5th power. We're just going insane. Go ahead and try this example. Alright. So let's go ahead and do this step by step. Now we've got actually a positive exponent this time on the outside. So we don't need to flip around this fraction or anything. Just leave it as is. If that was a negative exponent, your first step would be to flip around the fraction, the whole thing, because it was b to everything. Alright, but now I do still have these negative numbers. So go ahead and flip around the position of all the negative numbers. So this b to the negative 7, he now goes on top. That c to the 3rd stays on top. A to the 6th goes on bottom. I'm going to go ahead and leave it next to the other a to the 3rd. The b to the 10th goes on the bottom. Alright, we got rid of that b to the negative 7, and I'm left with c to the 4th. Now when there is a lot going on here, it might be easier to go ahead and kind of cross it out as you're writing it down. I'm going to go ahead and count up. I still have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I've counted for everything. And it's all to the 5th. Now let's simplify within it. I've got 7 b's divided by 10 b's. That means I'm going to be left with still 3 b's on the bottom. I've got 3 c's divided by 4 c's. That means I'm going to have 1 c left on the bottom. I've got 6 a's times 3 a's. That means I have 9 a's on the bottom. And I'm not left with anything on the top. Just have a 1, all to the 5th power. Now I can distribute the 5th power. Now 1 to the 5th power makes no difference, even though you're technically distributing there, because 1 times itself, no matter how many times, is still just 1. So then we have 1 over a to the 45, b to the 15th, c to the 5th. And then I'm done. Alright, I know that you mentioned that these were the ones you wanted help with. We're going to continue doing the wild and crazy examples. One more. If you want more, just let me know. So let's say I have a to the 3rd, b to the 5th, c to the negative 7, over a to the 2nd, c to the 5th, all to the negative 3 power. So since I've got the negative on the outside, go ahead and flip around your fraction first thing. Just flip everything around just to get rid of that negative. I know there's another negative in there, don't deal with him yet. Now we've got a negative on the inside. Go ahead and flip him around. Now I've got no more negative fractions, so I'm good. I mean, not negative fractions, negative exponents, so I'm okay. Now we can just deal with the positive exponents. So we look for pairs. So I've got 2 a's on top of 3 a's. That means I'm left with 1 a on the bottom. I've got 5 c's times 7 c's. That means I have 12 c's on the top. And the b, he has no friends, so he just stays as is. Now I can distribute the 3. So this means that I've got 3 groups of 12c. That means I ultimately have 36 of those c's. I've got 3 groups of a. That's a to the 3rd. I've got 3 groups of 5 b's. That means I've got b to the 15th. Alright, let's go back and let's do other stuff that's going to be on this test. So whenever I've got problems like the square root of 6 minus the square root of, let me think about this for a second, 72 plus 3 square root of 6. So the idea is that I want to combine like terms, and this time the like term refers to having the same square root. Now in order to figure out exactly how many like terms I've got to simplify all of these roots. Now 6 just breaks down into 3 and 2, which is no pairs. So the 6's stay as is. You'll eventually just rewrite them. 72 though I can break down. That breaks down into 12 times 8, I believe. I'm questioning my own sanity here for a second, so I'm going to double check that that actually works. That does not work. I am a liar. 72 breaks down into 8 times 9. I am a complete liar. 8 times 9. So 8 then breaks down into 4 times 2. 9 breaks down into 3 times 3. 4 breaks down again into 2 times 2. And I'm going to go ahead and cross off my middle step. So now I circle my like terms. I've got a set of 3s. I've got a set of 2s. And I'm left with 1, 2 underneath. So that then becomes the square root of 6 minus 3 times 2 root 2 plus 3 root 6. I broke out the 3 times 2 because that's what I pulled out, and I was left with a root 2 underneath. So that becomes the square root of 6 minus 6 square root of 2 plus 3 square root of 6. Now root 2 can't combine with these guys, but I can still take square root of 6 plus 3 root 6. That becomes what? 4 root 6 minus 6 root 2. And that is my final answer there. So let's try another one. Let's say I've got root 8 minus the root of 40 plus root 2. So now we've got to check, are any of these actually alike? So we break out root 8 into 4 times 2, 2 times 2, 40 is 4 times 10, 5 times 2, 2 times 2. And you can go ahead and cross off the middle steps you've already broken down. 2 is just 2, stays as is. Oh, that guy, you can't cross off that. So we've got a pair of 2s, and we're left with the 2. I've got a pair of 2s, I'm left with a 5 and a 2. So I've got 2 root 2 minus 2 root 5 times 2 plus root 2. 2 root 2 plus root 2 gives me 3 root 2 minus 2 root 10. And then I'm done. Alright, last major topic. I'll double check it in. Actually, forget anything. If I did, I'll record another video. Or you can just, we'll talk on Google Hangouts, that's fine. If I have root x plus 10 equals 10, let's say. The idea is I need to get rid of the square root. So I square both sides to get rid of the square root. Squaring and square roots are opposites of each other. So now I've got x plus 10 equals 100. Subtract 10, subtract 10. I've got x equals 90. And I'm done. Let's say I have 3 plus the square root of n plus 5 equals 6. Like I've got to get the square root by itself first before I start just squaring both sides. So subtract 3 from both sides. I'm left with n plus 5 underneath a root equals 3. Now you can square both sides. I've got n plus 5 equals 9. Then subtract 5. I've got n equals 4. Let's say I had even more going on in front of the square root. Let's say I had 7 plus 2 root x plus 3 equals 14. No, I want to make it more even. Let's say equals something that subtract 7, you're still even, so let's do 29. So then we subtract 7, we're left with 2 root x plus 3 equals 22. Divide by 2, divide by 2. Root x plus 3 equals 11. So I'm trying to get the square root by itself before I can then square both sides. Or else you'd have to FOIL, and nobody's got time to FOIL. Nobody wants to do that. So you've got to get the square root by itself. So then you get x plus 3 equals 121. Subtract 3, x equals 118. And you're done. So I hope this helps you review. Apologies for my one mishap I had earlier, but I'm recording this on software that doesn't really let me go back and edit that easily. So just is what is. I'd be happy to hop with you on Google Hangouts as well. Good luck.